Explain the facade design pattern. The facade design pattern is a structural design pattern that provides a simple and unified interface to a complex subsystem. Let's understand facade design pattern with simple diagram. The diagram shows a client at the top. The client never talks to the subsystems directly. Instead, it communicates only with a single class called the facade. The facade acts like a front door. When the client sends a request to the facade internally talks to multiple subsystems. In the diagram, these subsystems are subsystem 1, subsystem 2, and subsystem 3. The client does not know how these subsystems work. It does not care about the complexity, the order of operations, or the internal logic. Everything is hidden behind the facade. That is the core idea of the facade design pattern. It provides one simple, unified interface that wraps complex systems behind it. The facade simplifies interactions, reduces dependencies, and makes the entire system easier to use. In short, as the diagram shows, the client talks to the facade. The facade talks to all subsystems. The client never deals with complexity. Now let's understand this with a very practical and relatable example. We will build a home theater system that consists of multiple components, a DVD player, a projector, and a sound system. Normally, to watch a movie, you must turn on the projector, turn on the sound system, turn on the DVD player, set the volume, adjust the screen, and start playback manually. This is too much work and too much complexity. Instead, we create a facade class called Home Theater Facade that exposes simple methods like watch movie and stop movie. The facade hides all the complexity and orchestrates the subsystem internally. Here is the full working example. We begin by creating 3 subsystem classes. The first class is DVD player. It contains methods to turn on, turn off, and play a given movie. The second class is projector. It has methods to turn on, turn off, and switch to widescreen mode. The third class is sound system with methods to turn on, set the volume, and turn off. Individually, each of these classes needs multiple method calls. For a simple task like watching a movie, the client must call all of these manually. Now comes the facade. We create a class named Home Theater Facade. This class contains references to the DVD player, the projector, and the sound system. In the constructor, we inject these subsystem objects. Next, we create a method named Watch Movie. This method hides all complexity and provides a single clean interface to the client. Inside Watch Movie, we turn on the projector, switch to widescreen mode, turn on the sound system, set the volume, turn on the DVD player, and play the given movie. The client does not know any of these steps. The client only calls watch movie and everything just works. We also create a method called stop movie to turn everything off in the correct order. Now let's walk through the main method. We create the subsystem objects DVD player, projector, and sound system. We pass these objects to the home theater facade. Now to watch a movie, we simply call watch movie and pass Avengers. The facade internally executes all required operations in the correct sequence. After watching the movie, we call stop movie and everything shuts down properly. This demonstration clearly shows how the facade pattern simplifies complexity by exposing a single simple method while hiding all the intricate steps from the client. Now let's see. When should you use the facade pattern? Use the facade pattern when your system has multiple complex classes that the client should not have to deal with directly. Use it when you want to reduce coupling between the client and the complex subsystems. Use it when you want to provide a clean, simplified API for external clients while keeping the internal system flexible. In real projects, the facade pattern is used in Spring Framework Abstractions, JPA Entity Manager, Hibernate Session Factory, Servlet APIs, File Handling APIs, and Logging Frameworks. Here is the version you can directly speak in your interview. The facade design pattern provides a simplified interface to a complex subsystem. Instead of calling multiple subsystem classes manually, the client calls a single method on the facade, and the facade handles all complexity internally. It reduces coupling, improves readability, and makes the system easier to use. That is the complete explanation of the facade design pattern.